and thanks for having me. So my kids were born in Hamburg, so I have a great affinity to the name Otto, although we live now in the rainy northwest of England, and therefore thank you also for switching on the summer for me. It is much, much appreciated. It's probably the one day of summer I will have. Anyhow, so let's speak about data first. And when I'm not an engineer by trade, I'm a lawyer, believe it or not, but when I first started thinking about this, I thought, well, how much of this? Because we're all surrounded by data. It is, of course, invisible, and therefore, I thought, okay, how much data do we have? So I went on the internet, and when you Google this long enough, it's not actually that easy to find, but you will see that in the year 2017, the IP traffic, the global IP traffic amounted to 1,250 exabyte. Impressed? I asked myself, what on earth is an exabyte? Does anyone know? It's a very, very large number, 10 to the power of 18. And because we still have no clue what this means, I put a nice little picture behind it. This is the Library of Congress in Washington, D.C., which is the largest library in the world, unless you ask the Brits, they think they have about 5 volumes more. But the point is that you can store the entire content of the Library of Congress on an exabyte. 100,000 times over. So that means that last year we transacted information over the internet comprising 125 million times the largest library in the world. This is, of course, not where it ends. This is very close to where I live, and as you can see, sometimes there is blue sky. Jodrell Bank is, if you're an astronomer or a physicist, you would know it is one of the most famous radio telescopes in the world. And they are involved now in a really, really, really interesting project called the Square Kilometer Array. What they do is they put arrays, a kilometer squared, of telescopes, one into northwest Australia and one somewhere in South Africa. And the folks in Jodrell Bank, which is part of the University of Manchester, now their task is to handle that data. What happens when they switch these arrays on is that the data output of this planet will increase by a factor of 4. So I asked one of the professors who was working on this, and I said, how on earth are you handling this? You know, I mean, just imagine a broadband connection. You try to stream 5 times the entire internet. And he just shrugged his shoulders. This was like the short answer was, I have no idea. But, I mean, some of the world's leading research groups for data compression and analytics, etc., because of this, are now in Manchester. And of course, it doesn't end there either. So, by the year 2025, so not that long out, we will transact 180,000 exabyte every single year of data. And because we still don't know what this is, here's another picture. So if this dinosaur, augmented with my great Photoshop skills, would press download on a file of that size, and if you had done this just before it got extinct, that download would complete roundabout today on present day in broadband speeds. So it takes 65 million years to download that. Now, you will have seen this graph. You know it as Moore's law, whereby the number of transistors on a chip doubles roughly every 24 months, which no longer works really. But as we can see, data capture also starts to rise in this way. And one of the reasons is that the number of data sources that we all operate with is ever increasing. And we're thinking data sources? I'm talking about robots. Machines are coming, and we've all seen this. This is what was known as Industry 4.0, and the little Wi-Fi bits that they put around the computers and diggers, they signify that this is a connected device, which means it can capture data and it can transmit data. And the number of those is growing, growing, growing. And what we're then seeing, and this is an actual law other than Moore's law, this is Metcalfe's law, and the chap invented this in order to convince people that it would be a great idea to standardize an Ethernet port. And the formula says that the value of a network is the square of its nodes. And this is the picture that he used to illustrate that. And this is an important bit to bear in mind as I go through those slides going forward, because when you think of machines as a data node, then the value of those connected networks does indeed increase. And this is where a lot of that backdrop of our society in the future will come from. Now, when it comes to robots, they are not actually all that new. You know, we've had robots in factories for decades and decades and decades. You know, specifically, you guys will be familiar with what they do in warehouse logistics. This is an Amazon warehouse, and those little orangey things, they shuttle shelves around so that human beings can package them, but at least they don't have to run around anymore and capture, I don't know, your bottle of whiskey or biro pen or whatever by hand. This, of course, also works with very large boxes. Hamburg Altenwerder. Most modern container ports are largely automated, but it also works with much smaller packages. Does any one of you have one? This is a Roomba. 1, 2. There you go. So, you know, there's about, what, 10% of people in this room who are living with a robot in their home already. Now, if you're so inclined, there are whole websites that are specifically geared towards domestic robot helpers, and I have failed to look at any of your websites, but I'm sure that you sell them too. You can, however, also now build a house using a robot from proper bricks. And this, of course, has implications for the people who used to do this, because a robot builds 24/7. There is no normal human construction worker can build a house in 2 days. A robot doesn't go on strike, a robot doesn't get a bad back, and they don't want to have more holidays. There's pizza delivery. This is my favorite thing. Imagine you sit at home in the evening and you could have a pizza delivered by drone. So if you look at the little circle around there, this thing went live 1.5 years ago in New Zealand. But not somewhere on a sheep farm, it was Auckland. So that exists. And of course in Silicon Valley there's also a robotic pizza making startup somewhere. And if you think this is all too boring to have always pizza, there is also a robot that can cook at present 2,000 different recipes for you almost at a push of a button. Now you may have seen last year the world's greatest inventor, announcing the Tesla semi-truck, and I'm partial, I'm driving one, not one of those. But what people then often forget is that this is by far not the first one. Freightliner, which is Mercedes, I believe, they have been trialing fully autonomous trucks on roads in Nevada since 2015. So these things are going live pretty much any time now. And then there is the last mile deliveries, and there is a lot of experimentation going on, and I'm not sure if this thing works, or I'm not sure if that thing works. But at least, you know, it's last mile is one of those things where you should think, well, this is really, really tricky to handle because, you know, someone says, well, just leave it in the silver bin, or the other person was, well, you always have to deliver it to the granny next door, and if you're a human being, you know that. And those are things that robots find very, very hard, and we'll have to bear that in mind because those types of complexities, that might be where we are. Then I stumbled across this. And I have no idea why you would do that. This is a fully autonomous race car. So you don't have to pay Vessel or Hamilton many millions, but on the other hand, why would you drive a race if there's no bloody driver in it, right? So what it becomes effectively is a competition amongst programmers on who builds the most effective algorithm. Fascinating. I mean, things look cool. If you want to take it a nudge darker, though, you know, this could be your next policeman. Doesn't hire. This version is 5 years old. The new version, they introduced something really quite cool, and this will have a lot of impact on the way how we perceive these things. Because they basically introduced, someone called it's the concept of a metastable robot. You know, so amongst our humans, if this is not, you can see it here, so this is like slightly off. If I would stumble, then, you know, that's an imperfection in terms of how I move, but I can catch myself. Now, those robots can catch themselves. And you can try and kick them, etc. You should Google this or have a look on YouTube. It's quite funny. It's also quite cruel sometimes. But they're machines. Don't forget that. But that means all of a sudden you don't need to have the perfect machine. A good enough one that can adapt to its environments in real time might just be enough. And if you would travel to California today, one of the world's most beloved companies, Uber, uses this thing to control their parking lot and their parameters. Now, the next version can actually recognize a face, so it can see, okay, this is an employee who's just working late, or it can compare it to a criminal database and see, well, this is a known car thief, and alert the police straight away. If you have access to the dark web, you can buy one of these things right now and get people out of the way because they can target you, just like that. I stopped getting darker now, I promise. Now, I said earlier, I trained as a lawyer, and it is one of those classic things where daddy comes to you and says, son, study law or doctor or accounting, you know, you'll be good, this is a great career. It turns out that might not actually be the case anymore. Because when you think about this, lawyers, they like to think about this differently, I'm sure, but it is a lot of that work is a very standardized process. And whenever it's standardized and you have a set of rules against which to compare that, then a robot is potentially better than you. The same is true for accountants. The same is true for certain types of doctors. My father-in-law got an artificial hip a few years back. That was done by a robot. If you're a radiologist, it is very likely that this will be done by a robot. So we're not only talking blue-collar workers here, but we're talking very, very high-value workers as well. Now, this was in 2010 when something called the flash crash happened. Now, this dip that you see there represents $1 trillion in assets. And they were erased in seconds. And what no one had realized that already as far back as 2010, 60% of the world's financial markets were actually run by algorithms. So in other words, someone, I think they blamed it on fat fingers actually, someone just pressed the wrong button on a machine and all the trading algorithms in split seconds reacted to it and wiped off, well, I mean, this is a higher GDP than most countries in the world. So all of this stuff will have a massive impact on the workforce and employment, and by inference also on how we as society live. Because, you know, yes, we will certainly find new jobs, but let's face it, why will you become a white van driver? Very often because you haven't learned anything else. And people who haven't learned how to learn find it a lot harder to retrain. Because there's also Baxter. Baxter is an industrial robot. A Baxter is a new version of an industrial robot. This little hat is a camera array. And Baxter learns by watching. So, on this picture, Baxter folds a t-shirt, and he learns to do that, it learns to do that by watching people fold a t-shirt. And if you wanted to build a car, then it will probably take a few days or weeks to follow all those complex processes involved. But eventually it will be able to build a car. And I thought, wow, that's pretty impressive. Now then, I stumbled across Professor Nate Telex from Brown University in Boston, and she thought, well, wouldn't it be good if we could basically provide a translation mechanism that allows robots of different makes and different kinds to learn from each other? So if, let's say, you're in Japan, where this little Pepper robot rolls around on every expo at the moment, and Pepper stands in front of a big heap of laundry and asks itself, what on earth is this? What do I do with that? Then Baxter will basically say, hold my oil can, I have you. And we'll be able to teach Pepper how to fold shirts. This is also a bot. A bot is a robot without a body. Facebook last year at their F8 conference announced pretty staggering numbers on the use of Messenger, their messaging platform. And it's not WhatsApp. This is really only Facebook Messenger. So they had 1.2 billion users, and interestingly, 65 million businesses who were active on that platform. Now, most businesses run this using bots. A lot of it is customer service, some is sales, some is just mere information. Now, between those, more than 2 billion messages are being exchanged every month. And this means that 2 billion times a month, humans happily communicate with bots, with algorithms. And this was last year. And this chap in Osaka, he's not a robot. No, but he's the president. He tries to bring this whole thing together. And his latest creation is Erica, who is a robot. When you have a look on YouTube for videos of that, and you have a look at one version from 2015 and have another look from a version of late last year, you will see by now Erica speaks almost like a human. It is almost impossible to tell that it is not a human. So there we go. And if you basically say, well, you know, this is all hype, it is true, no one knows if this takes 10 years, 5 years, or 20 years. But what is 20 years in terms of for a society? What is 20 years for a company? What is 20 years for us as humanity? It is not much. And because there are data nodes, the whole thing accelerates ever more. And we have now one thing that helps it accelerate yet more, and that is AI. Because all these masses and masses and masses of data that we generate and accumulate, no human being can actually find their way through them and make sense of them. So AI. This is how it started. This is sort of like one of the first bits of AI I can remember. And this was when IBM's Deep Blue, shockingly, to every human person in the world, beat Garry Kasparov, who was then the undisputedly best chess player on the planet. Now, what you don't see on this picture is that behind there was effectively a room probably this size full of IBM computers that brute force computed against poor Kasparov. And everyone was, wow. Now, a few years later, IBM Watson beat these two guys on the sides. They were the two best ever Jeopardy players. And Jeopardy is, if you're not familiar with it, it is basically you have to find the question to a given answer. So in other words, the normal linear logic doesn't really apply. So it's a much, much harder thing for a machine to figure out. Watson did that, and did that in style, and so much so that the guy on the left basically held up his hands for humanity. It says something about welcoming the computer overlords. Now, about 20 months ago, well, probably 2 years ago, DeepMind, which is now part of Google, announced that they would run an experiment by which they would try to play the world champion in Go and try and beat him. And by world champion in Go, this is not just a world champion. This guy is the Roger Federer of Go. He hadn't lost a match in 10 years against anyone. And Go is a game so complex, chess is really for babies. I kid you not, because on a Go board, there are more combinations than there are atoms in the known universe. And what that means from a computing perspective is really quite significant, because it means you cannot brute force compute it. It is impossible. There is no computer until we have well-functioning quantum computers. But there is no computer that could compute that much data in any meaningful amount of time. So they asked before this, they asked one of the DeepMind founders, so in truth, what do you think? And he goes, well, it's probably another decade before we do this. But AlphaGo, the algorithm, beat the real guy 4-1. And astonishingly played moves that had never been seen before. The world champion now uses AlphaGo to train. And then about a year later, Google says, we have something better. And they presented AlphaGo Zero. And AlphaGo Zero, it took 36 hours of training. And what they did is they used 2 convolutional neural networks. One, the only thing it knew was the rules of Go. It had never played a game. It was never taught by anyone how to play the game, but it knew the rules. And the other one was calculating the probabilities of winning. And those 2 played against each other for 36 hours. And then they went on to play AlphaGo, who had just beaten the pulp out of the Roger Federer of Go, and beat it 100-0. If this isn't scary enough, they effectively ran it on a next generation mobile chip. In other words, with very, very low energy required to do this. That's where we are today. And if you look at specifically the last bits, we used to say that computers are extremely good at pattern recognition. I'm not sure what they would do out of a Jackson Pollock painting, but other than, generally they are really, really good at this. Now, AlphaGo and those types of algorithms that we're seeing now, they're actually a step beyond. This is not only about pattern recognition anymore. And who has the biggest bodies of data? I promise I haven't been putting this slide on only because of what happened the last few weeks. But this is a 2-year-old graph, and everyone who wants to know how much Facebook knows about you and what they do with it, you can find out. This whole graph goes another 5 meters further down. It's really, really good. So they teach you how they collect data and then how they store it, because they cluster it sometimes, depending on certain demographics or certain interests, etc. How they then process it in order to target you, because that is what Facebook does. They try and sell you advertising. And they want to make sure that you stay just interested enough that you stay a little bit longer so they can show you something more. Behind all those trends is, amongst some other people, this guy. Michał Kosinski is a young Polish researcher who is a professor in Stanford. And they basically looked at publicly available data, sort of Cambridge Analytica style, and try to infer, they basically try to interpret that data and see what they could do with it. This is what it boiled down to. And when he realized that, he was one of the first people warning against algorithms such as Cambridge Analytica's. A few years back, so we could have avoided a few of the worst decisions of recent times. So all those wonderful things. You know, how open-minded are you? Where do you lean politically? All that sort of stuff. They could read it from your face. So, if we leave the scary bit or the exciting bits aside, what these things offer us is more dimensions, because we now have more network nodes equipped with more sensors, and they generate more raw data. Now, raw data is useless, because it's a dark lake of data and it has no sense. But we can now apply machine learning and artificial intelligence to make more sense of that data and turn it into structured data sets. And this, in theory, does one thing, value neutral, but it gives us more sense of the world around us. And that opens a ton of unknowns because, everyone is scratching their heads, including the researchers on this. But it also gives us more opportunities. And I come to the final point, because I certainly asked myself, what is the impact on us? What does that mean? You may have read this quote in one way or another. Harvard says 47% by 2027. Stanford says 42% by 2030. No one knows exactly, but we all have this notion that this works. So let me ask you, if I want to become a diffractive optics modeler, what do I learn? Any idea? The closest I could come up with was physics, optics. Now, the scary bit is this is an actual job description from 2015, with arguably one of the wackiest and most secretive companies on the planet, whose things may or may not work. But they were actually looking for this. Now, we don't know what to learn. How do we educate people for that? This is one of those new jobs. So we as humanity, I think I can see two avenues that we have that bring a lot of hope to this. And the first is to ask ourselves, what is specifically human? And there are certain things that a machine can never do. And these are things made with love. This is the pattern for this jacket, which was made by my wife. Now, bespoke tailoring is one of those things. You basically, you can't rationally explain why you should spend a lot more than just buy a suit off the peg, because you can get pretty decent suits, but it's a process, and the tailor, and it's an emotional good that stands at the end. And no machine can do this. Empathy in general, and this is the postman who will actually deliver to the granny because he knows that guy again forgot that I had to deliver a parcel, but never mind, I deliver it to the grandma next door. This is anything that has to do with people and interacting with other people. Machines find that very, very hard. A machine doesn't know how you feel when you're hurt or when you're sad, because that's not a category a machine would use. Genuine creativity is another thing machines struggle with. And I'm not talking about all the monkeys hacking on typewriters until Ulysses comes out. That's the equivalent of brute force computing. And I'm not talking about some fancy algorithm that turns your photograph into something that looks from Van Gogh. That is just algorithmically fiddling with existing pictures. But how to be the next Van Gogh, that is generally hard. And the last thing is critical thought. And that is, our thinking systems are based largely on Aristotelian logic, which uses deductive inference to try and predict things forward. So we look at historical patterns, and then we try and come up with something. However, critical thinking allows us actually to handle new situations for which we don't have any history. An algorithm doesn't really function that way. It basically has to look at this, at a body of data that exists in order to try and predict forward. So there again, us humans have a lot of advantages. The second one, and that might sound a bit scary at first, but it is not actually scary at all, that is human-machine augmentation. And we're seeing this already a lot. For instance, the Amazon automated warehouse is effectively a machine helping a human do their job better. And now if you think of the most boring aspects of your job, and imagine you would have a robot buddy next to you that could do all those bloody reports and all those bloody Salesforce entries and all that stuff for you, and how much time that would free up for you to actually, bring your company forward, bring yourself forward, become more fulfilled in your life, both professionally as well as personally. And again, there is a lot speaking for this, because there are things machines are a hell of a lot better than we are, and they will be. It actually goes quite far, because this Elon Musk guy again, but also others, they work now on brain-machine interfaces. And my first reaction was, oh my God, until I read why they were doing this. And this was to, for instance, help blind people to see. This is for people who had bad brain injuries to regain cognitive abilities that had been lost. And when you look at it this way, then that's surely a good thing. It is important that we are aware of this and that we start acting on it. Now, my final thoughts on this, there is a lot of we in this. Because one thing I know is we can't leave it to governments. Governments are too slow. And not because I don't want to bash governments, but governments and democracies, they just take time until they get where they are. To change an education system takes a lot of time. There's a lot of inertia in these systems. And we can't really afford to wait until the German education system has figured out what we should learn to become a diffractive optics modeler. And this is also not a corporate social responsibility thing, because what happens is it serves society and it serves people, but it also serves the companies that we run. Because at the end of the day, if we're doing this better than our competitors, then we will stay ahead of that game. What we need to do is, because it is, the future is evolving slightly faster than it used to, and we have to stay on this. And that means lifelong learning. As our environments get more fluid, they will change all the time. No education system can be as quick as we are. We are at the pulse of this, so it is our honor, but also arguably our duty to act on it. And when you look at it this way, I think this is super exciting, because it actually allows us to shape our future. With that, I leave you, and thank you very much.